Hello, my name is Mincho Tonev. I'm a staff engineer working on the workload management feature in vSphere. With vSphere 7.0 U1, we introduced workload management with VDS networking or vSphere networking. Today, I will show you how you can enable workload management using such kind of networking. So first, I'll start with a short summary of what is vSphere with Kubernetes. So with 7.0 GA release, we introduced vSphere with Kubernetes, which enables the operations of vSphere admins to be able to deploy Kubernetes on vSphere clusters. This is crucial because we are moving now the deployment and the whole management responsibility not from the development team to the vSphere administrators. The value is that for the vSphere admin is that now it is easier to provide such kind of service, and you have the full control to manage, maintain, and secure such kind of deployment. From a developer's point of view or Kubernetes administrators, sometimes they are the same role, or but sometimes they are different. They can now easily get such kind of deployment without taking care of security, stability of the infrastructure, and they will get a full compliant Kubernetes cluster. So basically the workflow is vSphere admin provides such a setup. If a Kubernetes administrator exists, she will create a namespace so the developers can deploy their services, pods, and etc. on these namespaces. So with 7.0 GA, we introduced Kubernetes, but it was tied to the NSX. So in order to use it, you have to have a NSX with vSphere, so you can run such kind of setup. With vSphere networking or VDS, now you can deploy Tanzu Kubernetes clusters with your own networking. But this means that you should take care of the networking and the setup around that. So this is the workload platform architecture. As you can see, below is the S3C. On top, we have vSphere pod service, and this is actually the service, the core thing which provides the Kubernetes on top of the S3C. And we have, in this example here, two types of namespaces. So you can run pods natively on our NSXs, ESXs, on our supervisor control planes, but this is supported only if you have NSX. If you want to set up a vanilla Kubernetes cluster, you can deploy a Tanzu Kubernetes cluster and run your namespaces, pods, and everything over there. So with vSphere networking, only Tanzu Kubernetes cluster is supported. And as I said, it is very important that you understand the networking around all this, because you will be responsible for setting up the whole thing, which was before taken care on an NSX level. So there are mainly three important networks which we should differentiate between themselves. So first is the management network. This is the known network where the ESXis are residing. On those ESXs, we have supervisor control planes. Those VMs are maintained by vSphere, and they appear once the workload management is enabled on the cluster. Once that's done, and Kubernetes is running, we have namespaces. But those namespaces should deploy their workloads somewhere. And of course, this should be the workload network. Of course, it is recommended the workload network to be isolated from the management network due to security reasons. Of course, you can have more than one workload network. This is important if you want to, for example, isolate different namespaces and provide them to different development teams. With VDS networking, you have to deploy a load balancer. In our case, that is HA Proxy, which I will show you later, in order to route the traffic to the correct workload network and also expose the workloads to the external network. So this is the third type of network, the external network. In general, the external network and the workload network can be in the same segment, but they should be in layer 2 isolation, because supervisor control planes can get confused with the traffic. But of course, it is recommended these three types to be isolated. So in my setup, which I will show you today, I will use these networks and this configuration, and this is the network of my management network. This is the load balancer address range. What is this? This is the actually the address of the external network, also known as frontend network. So we will be able to provide a range of IPs. So HA Proxy will reserve them, so it can route the traffic through those IPs to the internal workload networks. In my example, I will use two types of workload networks, just to show that we can have several namespaces with different networks. And since we are deploying Kubernetes cluster, we have to have the services address range. We should provide them to the Kubernetes. And now I will show you the demo of how this all can be achieved. So initially, when you start and go to workload management, you see this screen. So you can either apply a license, or you can go and use trial license. So in my case, I will use trial license. So you have to choose your country and some phone number, of course. So you can, you have to agree if you're going to use the trial license with our end user license agreements, and there are on optional questions if you want to provide us with additional information. So when you click Get Started, you get navigated to this workload management page. So what is important about this page is that we will, here you see all the requirements in order to be able to deploy vSphere workload management on a cluster. So the first thing is that you have to have a proper network setup. NSXT is supported if you have such, and today I'll show you vSphere networking, which supports Tanzu Kubernetes clusters. And as I said, NSXT supports native vSphere pods. Additional requirement is that you have to have DRS and HA enabled on your cluster in order for workload management to work. Another thing which is important is a storage policy, because through the storage policies, we will find the correct data store and deploy the workloads on it. So let me just show you what storage policy is and how it should be configured in order to be able to deploy your workloads. So for my particular case, I've created this storage policy, which is just a tag-based storage policy. So as you can see, every data store which is tagged with WCP tag will be compatible. So it will appear here. So the workloads can go to this data store. Of course, you can tag more than one data store, so you can use two or more of them. Okay, the next requirement is to have a load balancer. So in order to deploy a load balancer, it's you can deploy it pretty easily. For this current example, I already deployed the HA Proxy. So to deploy the load balancer, you have to have the OVA of the HA Proxy. So you can pretty easily just search for HA Proxy VMware. So this is a blog post by Cormac. Most probably you know him. Most of the resources which I will provide in the end of the presentation are from his blog. So the HA Proxy is just an OVA, as you can see, which you have to deploy. And of course, you have to remember the username and password. So by deploying the HA Proxy, you have to put it into all the networks, because it is going to be used for routing. So as I said, I already have an HA Proxy deployed. So we can continue with the next step. And the next thing is a content library. So in order to be able to deploy Tanzu Kubernetes cluster, you have to have an image of it, which comes from a content library. So how you should configure the content library? Again, it is pretty easy. Content library, Tanzu, and you find pretty quickly the link. It is this one. So this is the link, and you have to just create a regular subscribed content library, which I already did. So as you can see, my templates are already downloaded, and we can deploy different versions of TKG clusters. So this was the last step prior being able to deploy enable workload management. So let's go quickly through the workflow. So as you can see in my setup, I don't have NSX, so I cannot select it. But if I had it, I would be able to choose between these two. So as you can see, we have warning that we should have HA Proxy, otherwise we won't be able to enable the workload management. And that's because NSXT is not detected, so this option is not available. So let's continue. On the second step, you have to select a cluster. But if for some reason, if your cluster is incompatible, you see it in this tab over here, and you'll be able to see the reasons of why a particular cluster is not compatible for enablement. So, for example, my other cluster over here, where I have set up the HA Proxy, doesn't have HA or DRS enabled, so I cannot use those. So if I select the cluster, I have to pick up a t-shirt size of my control plane VMs. So basically, once you enable the workload management, 3 supervisor control planes are deployed, and you're picking a size for them. So for my example, I will use tiny. And as I said, we have to choose a storage policy in order to for the workload management to find the data store where the workloads should reside. So this is my storage policy. Of course, I can double check if everything is fine and my data store is listed as compatible. So the next step is actually the HA Proxy. So I have the same environment opened here. So I just have to provide the deployment details, like the name, so HA Proxy. At the moment, we support only HA Proxy. I have to put the IP and the port through which the vCenter will, the workload management will communicate with the HA Proxy. So now I provide my username and password. And these are the fronted addresses which I mentioned in the presentation. So I will just copy them. So these are these addresses which I will reserve for HA Proxy. So it is important that once that's done, the HA Proxy will start responding to the pings to all of these addresses, because it will try to reserve them and not allow anybody using them. And I have to provide the certificate authority of the HA proxy. So in this case, I have to SSH to the HA proxy, and I have to go to HA Proxy. So here you find the certificate. So we have to provide it. So the workload management can trust that proxy. Okay, the next step is to provide the management network. So the control planes will be deployed on in the same network where the ESXs are residing. Actually, they're very well connected to the ESXs, and the ESXs know them. So it is pretty natural they to be in the same network. So here I should provide 5 addresses. I will have to provide the first one, but I have to provide 5 addresses which will be reserved for those control planes. So in my case, this is my network. I showed it into the presentation over here. This is my management network, and I've reserved the following IPs. So this is the first one, and the 4 IPs after will be reserved for the control planes. And the subnet mask in my case is this one. The gateway is the same as the one I use for my ESXs. The DNS is the same. So, and I have to provide an NTP server. So the next step is to provide the workload network. So as I said, this is important for Kubernetes to provide the IP range for the services. In general, this should be enough. But if you are planning to deploy more services, of course, you have to provide a wider range of addresses. In my case, I will use this range with the following DNS servers in the same subnet. You have to provide a network for your workloads. So if we return to the presentation, what we are building on this step is the primary and additional network. So those two are pretty much related to the VESs which I already have set up. So they're pretty much the same, and I will quickly show you the topology of those. Of course, the HA proxy should have accessibility to both of the networks, because there will be the actual workloads running. So now I will set up my primary network. So I will name it primary. And here is the gateway for it. the address range of the workloads and the subnet for it. So this is my primary one. Of course, I can set up a secondary network. So I'll do it quickly, just doing the same. So what is important here is that those two networks, my primary and my secondary network, should be L3 network isolated. So the workloads are not be able to communicate between those two networks together. And as I said, I have to add a content library so we can later deploy Tanzu Kubernetes cluster. So once all this is completed, I can verify if everything is as expected, and I can click the enable. So this enable will take some time. So as you can see, the OVF of the supervisor control planes are deployed. Here you see what is actually happening with the deployment. And if you don't have a license, you see an icon over here. So let's not lose some time because this will take probably an hour. I already have a setup where where my cluster is already enabled. So we'll go there. So as you can see here, the cluster is with running workload management. And if we navigate to it, you see that I already created some namespaces and TKG clusters. So once the workload management is enabled, you can start creating namespaces. And this is again in the role of the vSphere admin. So the creation of namespaces is very simple. You just provide a name. You decide which network it is going to use, and you can provide some short description. So once the namespace is created, you can start managing everything inside of it. So you can set limits. For example, the CPU, memory, and storage. You can provide for that particular namespace what kind of storage it is going to be used. So I will use the same. And you can provide privileges. So these privileges are important because these will be provided to the development team, so they can later on connect to this namespace and be able to deploy their workloads. And this is the link which you have to provide to the development team. From there, they will be able to deploy the download the required resources in order to be able to connect and manage their workloads. Actually, currently this is in isolated network, so this link won't appear here because I have to connect to it. But I can quickly show you how this appears. So there is a landing page with a simple button, where they can just download the CLI plugin for their platform and start running their workloads. Okay. So once you do this, you're pretty much done. But later on, of course, you have to manage your namespaces. So you can come here, see the utilization, see the health of the nodes. There are two types of events. Some are related to the Kubernetes, and some are the regular vCenter events, which we are all aware of. And you can do some additional modifications on the resources or object limits on that particular namespace. And the important thing here is that once a developer deploys something like a TKG cluster or a pod, you will see it here in the inventory. So you'll be able to monitor all the workloads, all the resources. You'll be able to see even what are the YAML files of those particular deployments. So these are read-only. As you can see, these objects are developer managed, but you can monitor and see and oversee what is actually happening. So this is pretty much what I wanted to show you today. I will share the links. In my opinion, these are very useful. If you want to go and deep dive into Tanzu and how to deploy particularly this cluster, it is 2-3 steps away to what I've showed you today. But these are videos, something like 2-3 hours, very well explained how to do that. These are blog posts from Cormac. Pretty much what I've showed you today, most of it. And if you want, you can try our hands-on labs. So this was pretty much all. And thank you.